Come back on another exciting video. Today we are here to talk about caching techniques. What is caching techniques? It's a fundamental technique used in computing to enhance performance and efficiency. In other words, caching is a technique used to store frequent access data in a temporal storage location called a cache. It involves storing copies of files or data in temporal storage location, allowing for quick access to frequent requested information. And also, this allows for faster access to data, reducing the time it takes to retrieve it from the original source. So the purpose of caching: we have speed, resource optimization, and improved user experience. With speed, caching reduces the time it takes to retrieve data, thus improving application responsiveness. And we have resource optimization, which is by minimizing the number of requests sent to backend system. Caching decreases service load and resource consumption. And the last one, improved user experience. Faster data retrieval leads to smoother and more satisfying user experience. Why cache, or benefits of caching? Performance improvement, which accessing data from a cache is significantly faster than retrieving it from a database or a disk storage. For instance, reading data from RAM can be orders of magnitude quicker than fetching it from the hard drive. So the performance improvement simply means it reduces load on original source. It reduces load on the original source of data. Yes. Thus, for instance, reading data from RAM can be orders of magnitude quicker than fetching it from the hard drive. So it reduces load on original source. And it's another one, which is reduced latency, which is caching reduces the load trip time for data request, leading to lower latency. This is particularly crucial for applications where real-time data access is essential. So reduced latency simply means less time spent. So the less time spent waiting for that essential data, that crucial application, the less time spent waiting for that data. Then we move to decrease load on backend system. Decrease load on backend system by serving cache data. Application can reduce the number of database queries or APIs call, alleviating pressure on backend servers and allowing them to handle more concurrent users. So, decrease load on backend system. When you decrease load on backend system, you get fast access. So decrease load on backend system, faster access. And when you get faster access, quicker the retrieval of data, the quicker the retrieval of cache data. Decreasing the load on backend system, the faster access, the quicker retrieval of cached data. So we move to types of caching, which we have memory caching, disk caching, and distributed caching. Memory caching simply means in memory caching, store data directly in RAM, allowing for extremely fast access. It is ideal for frequently accessed data that requires low latency. So, memory caching. Memory caching stores data directly in RAM. And RAM 2 is what? Is fast. The RAM is fast, but what? Limited capacity. So it stores data in RAM, whereby the RAM is fast, but limited capacity. You don't have large space to store many things. And we move to the disk caching, which also with disk caching is slower. Let's read this one, the disk caching. Disk caching involves storing data on disk drive. Storing data on disk drive, while slower than memory caching, it provides a large capacity for data storage. So storing data on disk drive, you get a large space. Like we have the hard drive. Yes, you are storing data on what? A disk drive. And a disk drive also have a large capacity. So that means it will be slower. So the difference between memory caching and disk caching is memory caching is fast, but what? Low or limited capacity. And disk caching is slower, but large capacity. As for example, for the memory caching, which is RAM, RAM is fast. And an example for the disk caching, which is hard disk drive, which is what? Large, which have large capacity, but what? Slow. Then move to distributed caching, which spread cache data across multiple servers or nodes, enhances scalability and fault tolerance. So the distributed caching, what it simply means is spread cache across multiple servers. And with all this, there are examples. So you can go with the distributed caching. We have an example over there. Then we move to caching strategies. With caching strategies, we have 4 of them, which is cache aside, read through cache, write through cache, and write back cache. So we will start with the cache aside, which is also known as the lazy loading. The cache aside, application checks what? Application checks the cache first. If the data is not found, it fetch it from the database and store it in the cache for future use. So the application what checks, that means the application what manages the cache. The cache aside, the application what manages the cache. That's the meaning of cache aside. The application what manages the cache. Then move to read through cache, which the cache automatically retrieves data from the database if it is not present in the cache. This abstraction allows developers to focus on application logic without worrying about cache management. So with read through cache, the cache retrieves data automatically. When the data is not on the cache, it retrieves the data automatically from the database. So when the data is not on the cache, it retrieves the data from the database when it is not present. Yes. So the read through cache retrieves data. It retrieves cache data automatically. And move to write through cache. Write through cache, data is written to the cache and the database simultaneously. With write through cache, data is written to the cache and the database simultaneously. So that means the cache and the original source must be updated simultaneously. When updating the cache and the database, it should be simultaneously. You need to update it simultaneously. You need to update the cache and the original source, which the original source is from the database. I said earlier on, when you go to the retrieve, what you retrieve what the data from the database when it is not present. So the original source is in the database. So you update the cache and the original source simultaneously when write through cache. And we move to the last one, which is write back cache, which data is written to the cache first and the changes are asynchronously written to the database. This can enhance written performance. Yes, it enhances written performance. It enhances write performance. It enhances write performance. Then we move to cache invalidation, which the meaning for cache invalidation is the process of ensuring that stale data is removed or updated in the cache when the underlying data changes. The cache invalidation is the process of enhancing the stale data. Enhancing what? The stale data. Enhancing the stale data is removed or updated in the cache. It's removed or updated in the cache when what? When the underlying data changes. So there are several methods of invalidation, which we have time-based expiration, which is cache data is set to expire after a predefined time period, ensuring that it is refreshed regularly. So there's time set for all the cache data, which when it's time to expire, to ensure that you refresh that expired data regularly, to stop that you refresh the predefined the expired cache data regularly. And move to events-based invalidation. The cache is invalidated based on specific events, such as data updates or deletions, ensuring that the cache reflects the list state. It reflects on the list state. And the last one is manual invalidation, which developers can manually clear or update the cache, typically used in scenarios where the application logic dictates changes. Cache size management, which cache eviction policies, which we have several policies. We have the least recent use, which remove recently accessed items first. This is effective to keep frequent access data in the cache. And we said that cache access frequent access data. It access frequently accessed data. So the LRU removes the least recent access data for keeping the frequent access data in the cache. And we have the first in, first out, FIFO, evict the oldest data first. This method is simple but may not always ensure optimal cache usage. And the last one, we have the least frequent used, evict the least accessed item over a defined period prioritizing keeping popular data in the cache. With this is whereby the old items are cleared and the popular data in the cache are prioritized. Yes. And move to the next slide, which is cache in web application, web caching. Web browsers cache static resources such as image, CSS, and JavaScript files to reduce load times on repeat visits. The benefits of web browsers, which is it minimizes service requests and improves page load speed, enhancing user experience. So the benefits of web browser is what? It improves page load speed, enhances user experience. Then move to content delivery network, which is another caching in web application, which cache static assets across geographical distributed servers, ensuring that users receive content from the nearest servers. And the benefit for the CDNS is reduces latency and improves load time for users worldwide, especially for high traffic websites. And we said that reduced latency is less time spent waiting for the data, and the less time it's spent, and that's to improve load time. You spend a less time and improve load time for users worldwide. And there are several challenges. There are 3 challenges, which we have the cache stillness, which data becomes outdated, and we have cache size limitation, which limited storage capacity, and complexity, which is implementing. And this is the end of the slides. So do well to subscribe to this channel, press on the notification button, then like and also share for other people to watch. Thank you.